Hello math people, I just wanted to do a quick video tutorial on, I think sections 2.2 all the way up to 3.1. I recorded a lot of these lectures on Zoom, but I realized that they're not always consistent in quality, and sometimes I actually forgot to record halfway through, and I don't think that's fair to you guys if you don't have the full recording. So I'm going to go back and go through these sections a bit slowly, and also I think that there were some theorems that Professor Arthur may have missed in his lectures, and so I just wanted to provide those to you here. So the first section that I'll be going over is 2.2, and that is quadratics. So our goal for today is to understand the vertex and the axis of symmetry, be able to convert to vertex form, be able to find the range and domain, and graph by hand, be able to graph these by hand and use your grapher to help. So these are equations. Parabolas are of the form ax squared plus bx plus c, and you should be used to these, and if you're not, we'll get used to them. So first off, what is the vertex? So the vertex is a coordinate h comma k. You always want to write this as an ordered pair. You never want to leave it like, you just always want to write it as a coordinate. So parentheses surrounding two values, right? So when a is greater than 0 in that ax squared plus bx plus c, it's going to be positive, right? So a is positive, which means the graph is going to be positive, it's happy, and it's going to have a minimum right here. And this is h comma k. And then if a is less than 0, our parabola is sad, it's frowning, it's a negative. And so we're going to have a maximum up here, and that's going to be also at h comma k. So how do we find it? So we have two steps. We take x equals negative b divided by 2a, and that's what's called our axis of symmetry. And then our second step is to plug in. It's very simple. So I'll do an example. So we have x squared plus 2x plus 3. Our first step is we're going to set x equals negative b, so negative 2, divided by 2a, which is 2. And that's going to give us negative 1. So our axis of symmetry is x equals negative 1, and I'm going to draw that right here. All right, so I've drawn our axis of symmetry, and our second step is to just plug in that value. We're going to have negative 1 squared, which is just 1. So negative 1 squared is 1, plus 2 times negative 1, which is minus 2, plus 3, right? And so this is going to be, what, 4 minus 2, which is 2. And so we're going to see that our vertex occurs at negative 1, comma 2. So this point right here is our vertex. And since a is positive, right, so we have our leading coefficient is 1, it's going to open up, and it's going to be happy. Also note that when x equals 0, our y-intercept is at 3. So here's another point. And Pearson will ask you to graph using those 2 points. So I'm going to draw that here. So on to our next topic. So when we know a, so we have ax squared plus bx plus c, and we know the vertex h comma k, then we can write the quadratic as a times x minus h squared plus k. And I'll just do an example of that. And also, if you want to see that this works, okay, so so we'll do x equals, and I'm actually going to change this. This was supposed to be, so x equals 3x squared minus 6x minus 2, okay? So step 1 is to find our axis of symmetry, and this is going to be x equals negative b, which is 6, divided by 2a, which is also 6. So our axis of symmetry is x equals 1, and I'm going to draw that here. So our second step is, of course, to plug in. So when we plug in 1, we get 3 minus 6 plus 2, or 3 minus 6 minus 2, and that's going to be negative 5, right? So our vertex occurs at 1, comma, negative 5. 1, comma, negative 5, right? So I'm going to plop that on our graph right here. And then our intercept is going to be at negative 2, right? So right here, our y-intercept. And so that way we can sketch the curve like this. Pretend I did a better job. And then our third thing is to write it in vertex form. So we know a is 3. We know h we got to be 1, so x minus 1. And then k is negative 5. Squared minus 5. So our final equation in vertex form is 3x minus 1 squared minus 5. And this actually sort of makes sense. So what we're doing here, if you remember from the scaling and stretching of graphs and transformations, this x minus 1 here, right? That's going to shift the parabola 1 unit to the right. So our original parabola kind of looks like this, right? So then the minus 5, so our new one is going to just be shifted to the right by 1. And then minus 5 is going to bring it down to the correct vertex. And then the a term, so this 3, is going to scale it properly. It's going to stretch it. That helps me remember it at least. So we're literally just centering the parabola on the vertex. So 3 more examples of just finding the vertex from the vertex form. So right here, the vertex is going to be, so x minus 5. What makes it 0? So when x is 5, this becomes 0. So our vertex is at 5. And then our y-coordinate out there is 6. Our vertex, likewise here, is going to be negative 2, comma, negative 1, right? Because we have x plus 2, a negative 2 would make that 0. And finally, right here, we have 0.25, comma, 0. Because out here, we have a plus 0, right? And again, in Pearson, they're going to ask you to place a point at the vertex, and they're going to ask you to place a point on the y-axis. We'll do this little example here. So x equals negative b over 2a, right? That's going to be negative 6 divided by negative 2, which is 3. So our axis of symmetry is x equals 3, and I'm going to draw that here. It's going to be, I'll use orange. So here is our axis of symmetry right here. Maybe hard to see. And when we evaluate at 3, we have 6 times 3, which is 18, minus 3 squared, which is 9, minus 5. Okay, so this is 18 minus 9, that's 9, minus 5. So our total result is 4. So our vertex is going to be at 3, comma 4, right? And then our parabola is frowning. So this is a maximum right here. But when x equals 0, it's going to be at negative 5 down here, right? So that means our parabola is going to look something like this. All right, so finally onto our last topic is domain and range. The domain is always going to be negative infinity to infinity because we can plug in any x value we want, right? But the range will depend on whether or not a is less than or equal to 0, or is less than or greater than 0. So if a is positive, our graph is happy, right? And we have a minimum right here. So if this is h comma k, our vertex, then we see that our range is going to be from bottom to top. So that's k, and including k, all the way up to infinity, right? It's unbounded as it goes up there. If the vertex is, if a is less than 0, then our graph is sad, it's negative, it's frowning. And this is still our vertex, h comma k. And so the range is going to be negative, our range is going to be from bottom to top, so negative infinity, it goes as low as it wants, all the way up to and just reaching k. In 2 examples here, we'll do y equals 4x minus x squared plus 2. So step 1, let's find the vertex. So x equals negative b, which is negative 4, divided by 2a, which is negative 2. So x equals 2. And then we're going to plug that in. So we have 4 times 2, which is 8, minus 2 squared, which is 4, plus 2, and that's going to give us 6. So our vertex is 2 comma 6, and since a is negative right here, right, so a is less than 0, our graph is going to be frowning, it's sad, it's negative, and that means our range is going to go from negative infinity all the way up to 6, right? On the other hand here, when we have it in vertex form, this is kind of free. So we see that a is greater than 0, it's positive, our graph is happy, it's smiling. And we're going to have a minimum here. So our range is going to be all the way from negative 6, this value right here, all the way to infinity. Finally, some graphing tips. So I'm going to draw a really rough sketch of your calculators here. So it's going to look like this. This fifth button on this second button on the top row here, it's going to say window on it, and I'd like you to press that. So when you have a quadratic equation and you put it into your y equals, first you want to find out your vertex, h comma k. Second, you're going to press window on your calculator, and you're going to set your y min and y max to like surround k, and your x min and x max to surround h. So let's take this one, for example, right? So we know the vertex is at 3 comma 4, right? 3 comma 4. And what that means is that we want to have our window, capture that point, right? And we want it to kind of go more further down because that's the maximum, right? So 4 is the maximum. So I would have it just kind of up to here. And then To capture our x values, I'd probably go to -3, and then to balance it out, I go plus 6 more in the other direction, so I go out here. But basically, you just want to box in the important parts of your function, if that makes any sense. I hope that this little video tutorial was helpful, and I will make another one for 2.3.